Hello everyone, my name is Amir Hafiz. I'm the doctoral candidate one from the Innova project. My presentation topic is about active device casing for noise reduction. In this presentation, I'll talk about active structural acoustic control as a concept. I will also talk about few types of noise sources which are applicable to the active device casing method. Then I'll talk about a general description of a multi-channel system and also mention a few types of control system architectures. Finally, I will then conclude this presentation describing my scope of work. Starting with the problem definition. There are many sources of noise. It can be categorized as stationary or dynamic noise sources. Here in our problem, we're considering stationary sources such as the examples shown here. We have a set of machines that can induce noise. A great example of these machines are compressors or pumps, or in general, any device that has a moving mechanical parts. It can also induce noise. Some of these devices can be designed with an encapsulated structure, such as a casing. And that casing can take a shape of a box, for example, as shown here. This can be supplemented with sets of sensors and actuators, so this can reduce the noise level of the surroundings, which is basically applying the concept of active structural acoustic control. So shortly we call it ASAC. In this animation on the left side, this represents a noise of a machine that is placed inside the casing. This barrier here represents a plate or any plate of the casing. It has sets of structural actuators placed on it from the interior side of the plate. So basically the actuators are placed inside the casing. And outside there are sensors that capture the emitted noise that is caused by the machine itself. Using these signals from the sensors, we can use it as a feedback signal. This way, it is possible to reduce the noise by driving the actuators using adaptive multi-channel algorithms. Um, since it is important to reduce the noise levels of the surroundings, as in globally, it is required to use an adaptive multi-channel algorithm for the ASAC system. They're provided here is a multi-channel, is a general description of a multi-channel feed-forward system. Considering a single noise source, one reference sensor is sufficient for the system, and the remaining sensors are feedback sensors where we want to actively reduce the noise at by driving the sets of the structural actuators. Um, all the signals from the sensors are fed back into the multi-channel control system as shown here. Um, so now conventionally there are three types of control system architectures. The first one is a decentralized control architecture as shown here. Here the control filters are reducing the noise independently from each other. So each control filter is using a single feedback signal. Um, Generally, this architecture has the lowest computational requirement and can be exceptionally unstable at some frequencies of the noise due to some coupling effect. Uh, the second architecture is a centralized control architecture. Each control filter and the multi-channel effects NMS is using multiple feedback signals, so it can reduce the noise level for each sensor simultaneously. This architecture basically increases the computational complexity of signal processing, but ultimately it makes it stable. Uh, the third architecture is a distributed control architecture. Uh, it's similar to the decentralized, but instead there is sharing of information between the nodes, so that each control filter can compensate the output of another. It similarly has the computational complexity of a centralized architecture, but is very stable and has similar performances. So, what is the scope of my work in the project? I'll have to phrase this as a question so it can be understood easier. So, how to reduce the computational complexity of a system with minimal impact on stability and performance? I'm currently working on a numerical model of a large-scale system. I'm using a method that reduces the feedback signals required for the control algorithm. This can be done by sorting magnitude responses obtained from secondary path models of a system. Uh, this method combines a mix of centralized and decentralized control filters, which basically causes a trade-off in trade-off between computational complexity and stability. Um, This can be potentially effective for large-scale systems. So, speaking on when there's higher amount of actuators used by a system. Uh, for now, this is the general workflow of the proposed system. On the right-hand side, we have adaptive processes. Each control filter requires a reference and an error signal. This SM refers to a temporary feedback selection matrix that is calculated by a sorting algorithm that I spoke about earlier. This is basically responsible for, this matrix is responsible for which control filter controls which feedback sensor. The selection algorithm is currently using information from the second path models, but it will be reinforced with spectrum data from the noise. And for now, my colleague Ivana, doctoral candidate 10, she will handle the presentation from here. She will talk about application of virtual sensing and structural sensors for aircraft cabins. Thank you very much for listening.